हेलो फ्रेंड्स, कैसे हैं आप सभी। उम्मीद है आप सभी अच्छे होंगे। आज हमारा जो टॉपिक है वो है इंट्रोडक्शन टू डीसी मशीन। स्टार्ट करने से पहले आई वांट टू इंट्रोड्यूस माई सेल्फ महेंद्र कुमार, असिस्टेंट प्रोफेसर, डिपार्टमेंट ऑफ इलेक्ट्रिकल इंजीनियरिंग, स्कूल ऑफ इंजीनियरिंग टेक्नोलॉजी, IFTM यूनिवर्सिटी मुरादाबाद। टुडे आई एम गोइंग टू present a topic on machines where we will study about the DC machines। तो फर्स्ट ऑफ ऑल हमारे माइंड में आता है कि DC मशीन क्या होती है, इसकी रिक्वायरमेंट क्या है या फिर इसका वर्किंग प्रिंसिपल क्या है। तो सबसे पहले हमारा आपने पढ़ा होगा कि जो इंडक्शन DC मशीन की हम बात कर रहे हैं, DC मशीन हमारी नॉर्मली आपके फ्लेमिंग के रूल्स पर हमारी वर्क करती है, जिसमें हमें DC मशीन को पढ़ने से पहले हमें जो फ्लेमिंग के राइट हैंड रूल एंड लेफ्ट हैंड रूल हैं वो हमें पता होने चाहिए। तो आप स्लाइड में देख सकते हैं कि यहाँ फ्लेमिंग का लेफ्ट हैंड रूल डिस्क्राइब किया गया है, जिसमें आपका फिंगर और थंब की डायरेक्शन आपको दिखाई गई है, करंट की डायरेक्शन, मैग्नेटिक फील्ड की डायरेक्शन और डायरेक्शन ऑफ फोर्स, ये आपको शो हो रही है स्लाइड में। तो फ्लेमिंग का लेफ्ट हैंड रूल है क्या, तो आपने देखा फिगर में, आपने देखा किस पोजीशन में अपने हैंड को रखना है। ये यूज कहाँ हो रहा है कि इट यूज टू डिटरमाइन द डायरेक्शन ऑफ द फोर्स एक्टिंग ऑन ए करंट कैरिंग कंडक्टर प्लेस्ड इन ए मैग्नेटिक फील्ड। द मिडिल फिंगर, the forefinger and the thumb of the left hand are kept in the right angle to one another. The middle finger represents the direction of the current. Middle finger आपकी करंट की डायरेक्शन शो करेगी. The forefinger represents the direction of the magnetic field and the thumb indicate the direction of the force acting on the conductor. This rules applicable for DC motors. Now Fleming's right hand rule. In this PPT you can see the direction of the thumb and the forefinger and the middle finger. It is used to determine the direction of the EMF induced in the conductor. The middle finger, the forefinger and the thumb of the left hand are kept at the right angle to the one another. The forefinger represent the direction of the magnetic field and the thumb represent the direction of the motion of the conductor, and the middle finger will indicate the direction of the induced EMF, and this rule is used in the DC generators. Now Lenz's law, it is very important to understand the direction of the EMF induced in the electrical machines. The direction of the induced EMF given by the Lenz's law. According to this law, the induced EMF will be acting in such a way so as to oppose the very cause of production of it. इन द सिंपल लैंग्वेज वी कैन से दैट द लेंज लॉ का क्या कहता है। लेंज लॉ ये कहता है कि वह उसी जो EMF इंड्यूस्ड हो रहा है वो उसी करंट का अपोज करेगा जिस करंट के कारण वो प्रोड्यूस हो रहा है। नाउ DC जनरेटर, वी नो दैट द जनरेटर, व्हाट डू यू, देयर इज अ बेसिक क्वेश्चन समटाइम आस्क्ड इन द इंटरव्यू, व्हाट डू यू understand, what do you mean by the generator? Then in simple language we can say that the generator is a mechanical device which convert mechanical energy into electrical energy. There are three requirements are essential: conductor, magnetic field and the mechanical energy. Working principle, I think that you all aware with this. I will explain. A generator works on the principle of the Faraday's law of the electromagnetic induction, where whenever a conductor is moved in the magnetic field, an EMF is induced, and the magnitude of the induced EMF is directly proportional to the rate of the change of the flux linkage. This EMF causes a current flow in the conductor. Circuit is closed. I hope you are getting my point. Now it is the cut view model of the DC machines, where you can see that you can see the commutator, bus, field winding and the yoke, armature core and the shaft also. It is a sectional view of the DC machine. You can see the field winding, pole shoe, interpole, commutator, frame and armature, conductor, load resistance, road restraint and shunt poles. You can, and the rotation of the direction also you can see in the figure. Now came to the construction of the DC generator. Normally अगर हम बात करते हैं किसी भी मशीन्स की, रोटेटिंग मशीन की, तो देयर आर ओनली टू पार्ट्स. फर्स्ट वन इज द रोटर एंड सेकंड वन इज स्टेटर इज ए स्टेशनरी पार्ट एंड रोटर इज ए रोटेटिंग पार्ट। फोर हम याद करने के लिए कैसे कर सकते हैं कि आर फोर रोटेटिंग, आर फोर रोटर। तो रोटर हमारा रोटेटिंग पार्ट है एंड एस फोर स्टेटर, एस फोर स्टेशनरी मीन्स स्टेशनरी पार्ट हमारा स्टेटर है। In the simple construction of the DC generator, the field system, armature core, and the armature winding commutator and brushes are there. At the field winding, you can see, and the rotor and the rotor winding you can see in the figure. A working principle: when the electrical current passes through a coil in magnetic field, the magnetic force produces a torque which turns the DC motor. You can see the direction. Armature winding, there are two types of winding. First one is the lap winding and second one is the wave winding. In the lap winding, the parallel path is equal to the number of poles. The armature winding are divided into number of the sections equal to the number of poles. I already explained. And in the wave winding, the parallel path will be 2. It is used to low current output and high voltage. Field system consists of the following parts: yoke, pole core, pole shoes and the field coils. Armature cores, the armature core is cylindrical, high permeability silicon steel stamping impregnated, and the lamination is to reduce the eddy current loss. Commutator, you can see it is not, I will not explain all the points, you can understand easily. Now came to the next slide, EMF equation. We have to generate the EMF equation of the DC machine, where we have to explain all these terms: phi n, p is pole, phi flux, and n is the speed, and after the calculation the EMF equation will be E is equal to, for generator we are using the EMF G for generator, p phi n z upon 60A. And from this equation we can also calculate the speed of the generator. Types of DC generator, there are mainly two types of machines in DC machine. First one is generator, which we are discussing, and second one is the motor. DC generator are generally classified according to the method of excitation. There are two type of excitation system in the DC machine. First one is the separately excited DC generator, second one is the self-excited DC generator. Further classification of the DC generator we can further divide into the series wound generator, shunt wound generator, and compound wound generator. Shunt, short shunt, and the long shunt and commutatively compound or differentially compound generator. Losses in the generator, when we are talking about the losses, there are various losses which can be defined as a copper loss or the variable losses, stir losses or the constant losses. Stir losses consists an iron losses and the core losses and the windages and the friction losses. Iron losses occurs in the core of the machine due to the change of the magnetic flux in the core. Consist of the hysteresis loss and eddy current loss. Hysteresis loss depends upon the frequency, flux density, volume, and the type of the core. Now move to eddy current losses. Directly proportional to the flux density, frequency, thickness of the lamination, windages, and the friction losses are constant due to the opposition of the wind and the friction. Now DC generator is complete. Now move forward to the DC motor. Sometimes someone called asked what do you mean by motor. The motor is electrical machine which convert electrical energy into mechanical energy. Convert electrical energy into mechanical energy. Construction same as the generator. The motor working principle: whenever the current carrying conductor placed in magnetic field, जब किसी current carrying conductor को magnetic field में रखते हैं, ये force is set up on the conductor. जो को हमारे conductor पे क्या बनेगा, force हमारा प्रोड्यूस होगा, जो हमने फ्लेमिंग के रूल के अकॉर्डिंग देखा था कि फोर्स की डायरेक्शन क्या थी हमारे. The back EMF, in case of the motor there is a back EMF. The induced EMF in the rotating armature conductor always acts in the opposite direction of the supply voltage. According to the Lenz's law, the direction of the induced EMF is always so as to oppose the cause producing it. In a DC motor, the supply voltage is the cause and hence this induced EMF opposes the supply voltage. Classical DC motor like the classification of the DC generator. The DC motor also classified into three main parts. First one shunt motor, second one series motor, third one compound motor. And compound motor further divided into the two parts: differentially compound and cumulative compound. It is the circuit diagram of the separately excited DC motor. We have to use the separate DC source to excite the field winding. It is the equation. You can see the equation of the voltage, and it is the torque speed characteristics of the DC motor, where we can see that when the torque will when the speed will, you can see that is the torque and the speed of the motor. The speed will be slightly when the speed will be maximum, the torque will be minimum. You can see in the graph. Speed control now is a major factor how we can control the speed of the DC motor, because according to the requirement of our applications, we have to control the speed of the DC motor. Control means we have to increase or decrease the speed according to the speed equation of the DC motor, and EB by phi. There are we can control the speed of the by flex control method, phi, and armature control method by changing the armature resistance, which is turn in change the voltage applied across the armature. Starter of the DC motor. There we need the starter to start the DC motor to limit the starting current. We can use two types of the starter. First one is the 3-point starter, and second one is the 4-point starter. Now there are the applications of the DC machines: shunt motor, blowers, fans, and centrifugal, and the reciprocating pumps, lathe machines, machine tools, milling machines, drilling machines, etc. In series motor, we can use in the cranes, hoists, elevators, trolleys, conveyors, electric locomotives, and cumulative compound motor in rolling mills, punches, shears, heavy panel, elevators also. Thank you. I hope the basic information about the DC machine you will get by this video. I hope you will enjoy, and best wishes for your career. Thank you very much.